Now I'm going to build a tree diagram to show the probabilities for this question. Now the question is, a customer orders from either supplier 1 or 2 and prefers supplier 1 60% of the time. On-time delivery rates, 90% for supplier 1, 80% for supplier 2. If the customer places 2 orders and both are delivered on time, what's the probability that both orders are from supplier 1? So this question is quite complicated because we have 2 suppliers and they have different delivery rates, so on-time rates, and we have 2 orders. And the 2 orders may be from different suppliers. So we need to define some events just to simplify all those events. Let's start with O, Ij, so subscripts Ij are the suppliers. So we have O11 for the 2 orders are both from supplier 1. O12 would be the first order is from supplier 1 and the second from supplier 2. So we would have 4 events using this O, right? We will have O11, O12, O21, O22. So we have 2 outcomes if our question is only about where we put the 2 orders. But we still have deliveries. We define event T as both orders are delivered on time. Now, why do we only define this one situation? Because for 2 orders, maybe one is on time, the other is delayed, or both delayed, etc. We only define this T for both orders are on time because that's the only situation the question is asking us to do. That's why I'm not going to exhaust all possible outcomes if we look at deliveries. From the question, we sense that the delivery, whether it's on time or not, is dependent on which supplier, right? If supplier 1, the on-time rate is higher than from supplier 2. So we can't say that the supplier is independent from delivery. But since we have 2 orders, can we say that these 2 orders are independent? Right. So when you place an order, for example, you are placing 2 orders here, we have 2 suppliers. If you have ordered from supplier 1, do you have to order from supplier 1 for the second order? No, at least the question does not give any information on that. So we assume that the 2 orders can be placed independently and the 2 deliveries are done independently. So we assume the independence for those 2 situations because we don't find any information from the question to contradict the independence. Now, with all these defined and assumed, we can start writing some probabilities. The probability that both orders are from supplier 1, so I have the probability of O11, it would be the product of the probability that the first order is from supplier 1 times the probability that the second order is also from supplier 1. Why this probability is a product of 2? Because of independence. So 0.6 is the probability of an order from supplier 1, so we squared it. Now the second O12 is the first order from supplier 1, the second one is from supplier 2, so we have again used independence. So we have this result. And we do the same for the remaining 2 outcomes if we only look at from where the 2 orders are placed. This is a good start for the tree diagram because this is how things would naturally happen in practice. Right? You first place the 2 orders, then you wait for deliveries. So this is the first level of our tree. On the second level, we'll start looking at the deliveries. So if we have both orders from supplier 1, what's the probability that both orders are on time, so delivered on time? If you have one order from supplier 1, the on-time delivery, the probability to have on-time delivery is 0.9. Now we have two orders. Remember, we assumed independence of the two deliveries. That's why we square this 0.9 probability. Apart from the event that both orders are on time, the rest, T prime, would be both orders not on time or one of the two is not on time. And do we need to worry about this? Not really. Because the question only asks you about given the two orders are delivered on time, what's the probability that both orders are from supplier 1? So we just need to extract the information when both orders are delivered on time. So whether one is delayed or both delayed, we don't care. Let's try to find the final two outcomes. Now these two outcomes are just part of our overall outcomes. They mean, or one of these, T intersect 011. That means both orders are from supplier 1 and they are both delivered on time. So we have the result for this probability. The other one, again, we don't care. Let's look at the lower two branches. So if the first order is from supplier 1, the second is from supplier 2, what's the probability that both are delivered on time? So from supplier 1, you have 0.9 probability to be on time. From supplier 2, 0.8. So you multiply these two. And that's how you get another two outcomes. And do the same for the other two. Now we have the tree completed. From this tree, we set up the probability to answer the question. If the two orders are both on time, so that's the condition. Given T, so both orders are delivered on time, what's the probability that both are from supplier 1? Now, based on what we've defined for the events, we wrote the probability like this. Obviously, a conditional probability. You write it out using this ratio. Where to find this 011 intersect T? It's directly on the tree, the very first outcome. And then the probability of T, that means no matter what the two orders are from, what's the probability that they are both delivered on time? We have a lot of T's among the 8 final outcomes of the tree. So we gather those that include this T. So we ignore those T primes. So we have the sum of all these probabilities, which give us the final answer.